Okay, so looks like 8 and 10 are kind of first on the to-do lists. Obviously, if you see something else in the course of this that you feel like you want to talk about, we're happy to do more. We'll start with number 8. So we'll start by just setting up the problem. So the divisor, that's the second number in our division problem, goes on the outside of our division bar. And the dividend, that's the first number, goes underneath. Just ask ourselves, how many times does x, the 2x to the fourth? Well, that's going to be 2x to the third, because 2x to the third times x gives me 2x to the fourth. And I multiply that to both parts of my divisor. And then I subtract. And one of the most common places that students make mistakes is forgetting to distribute this negative. So let's make sure we do that right now. So negative of a positive is negative. Negative of a negative is positive. So 2x to the fourth minus 2x to the fourth is 0. Negative 9x to the third plus 10x to the third is just 1x to the third. And then we'll bring our next term down. And then we'll repeat. So we'll ask ourselves, what times x gives me x cubed? Well, that should be x squared, because x squared times x gives me x cubed. So I'll multiply that to both parts of the divisor. So x squared times x is x cubed, and negative 5 times x squared is negative 5x squared. And then we'll subtract down. Again, before we combine like terms here, we'll distribute the negative. So negative of a positive is negative. And then negative of a negative is positive. So x cubed minus x cubed is 0. Negative 12x plus 5x is negative 7x squared. Oops, I meant squareds on all those. And then we'll bring down the next number. And then we'll go back to the top and ask ourselves, how many times does x go into negative 7x squared? Well, that would be negative 7x, because negative 7x times x gives me negative 7x squared. So I'll multiply that to both parts of the divisor. So we get negative 7x squared plus 35x. And then we'll subtract down. Now it's time to distribute the negative. So negative of a negative is positive, and negative of a positive is negative. So negative 7x squared plus 7x squared is 0. 29x minus 35x is negative 6x. And bring that last number down. And we'll go back to the top and ask ourselves one more time, how many times does x go into negative 6x? Negative 6 times, because negative 6 times x gives me negative 6x. So I'll multiply that to both parts of the divisor. So I get negative 6 plus 30. And then we'll subtract. Again, we need to distribute that negative. So a negative of a negative gives me a positive. And a negative of a positive gives me a negative. And negative 6x plus 6x is 0. Positive 30 plus or minus 30 is 0. So this is remainder 0. So we can say that our answer then is just 2x cubed plus x squared minus 7x minus 6. And we don't have to include any remainder because it turns out that x minus 5 is a factor of 2x to the fourth minus 9x cubed minus 12x squared plus 29x plus 30. So we got a whole number result. Joe, was that help?
Yeah, that was very helpful. Thank you.
Sure. Megan, you wanted to do number 10. So let's do that one next. So again, the initial setup is exactly the same. But here we have to be a little bit more careful when we're writing in our dividend, because you notice that we go from x to the 6th to x to the 4th. So I'm going to put a 0x to the 5th there. And then here we go from x to the 4th to x squared. So I'll put a 0x to the 3rd there. And we go from x squared to the constant, so I'm going to put a 0x in there. And it's really important that we remember to do this because it makes our lives much, much easier because everything is going to line up really nicely if we include those zeros in a way that it won't if we don't include the zeros. So that's going to make a big difference for us. Okay, so there's my initial setup. So again, make sure that you include those zeros for the missing terms. That makes life considerably easier and the problem goes much, much smoother if you do that. So we'll start at the top and ask how many times does x squared go into x to the 6th? Well, that would be x to the 4th, because x to the 4th times x squared gives me x to the 6th. So now I'll go ahead and multiply this to the entire divisor. So that gives me x to the 6th plus x to the 5th minus 6x to the 4th. And then we'll subtract. So we'll go ahead and distribute that negative. Negative of a negative. Negative of a positive is negative, and negative is positive. And we'll go ahead and combine. So x to the 6th minus x to the 6th is 0. X to the 5th minus x to the, or 0x to the 5th minus x to the 5th is negative x to the 5th. And negative 14x to the 4th plus 6x to the 4th is negative 8x to the 4th. And then we'll bring down the next piece. And then we'll go back to the top. We'll ask ourselves, okay, how many times does x squared go into negative x to the 5th? Well, that's just going to be negative x to the 3rd, because negative x to the 3rd times x to the squared gives me negative x to the 5th. Go ahead and multiply that to the entire divisor. So that gives me negative x to the 5th minus to the 4th plus 6x to the 3rd. And then we'll distribute our negative. So negative of a negative gives me a positive. And negative of a negative gives me a positive. And negative of a positive. So then we add or combine these like terms. So negative x to the 5th. X to the 5th is 0. Negative 8x to the 4th plus 1x to the 4th is negative 7x to the 4ths. 0x cubed minus 6x cubed is just negative 6x cubed. And we'll bring the next piece down. And so we'll ask ourselves now, how many times does x squared go into negative 7x to the 4th? Well, that's going to be negative 7x squared, because negative 7x squared times x squared gives me negative 7x to the fourth. So we'll go ahead and multiply to the whole divisor. And then subtract down. So we'll go ahead and distribute our negative now. So negative of a negative gives me positive. Negative of a negative gives me positive. And then negative of a positive. So negative 7x to the fourth plus 7x to the fourth is 0. Negative 6x to the third plus 7x to the third is 1x to the third. 49x squared minus 42x squared gives me 7x squared. And we'll bring down the next term. And we'll go back to the top. We'll ask ourselves, how many times does 1x cubed? Well, that should be easy to see that it's just going to be x times, because x times x squared is x cubed. And then we distribute the divisor. So it gives me x cubed plus x squared minus 6x. And subtract down. Distribute through our negative, so negative of a positive is negative. Negative of a positive is negative. Negative of a negative is positive. So x cubed minus x cubed is 0. 7x squared minus x squared is 6x squared. 0x plus 6x is 6. And then we bring that negative 36 down. Last step here. So I'm going to ask myself now, how many times does x squared go into 6x squared? Well, the answer is 6 times, because 6 times x squared gives me 6x squared. And so we'll distribute that to the whole divisor. So that gives me 6x squared plus 6x minus 36. And then I'll distribute through my negative. Negative of a positive is negative. Negative of a positive is negative. Negative of a negative is positive. And we combine our like terms down. 6x squared minus 6x squared is 0. 6x minus 6x is 0. Negative 36 plus positive 36 is 0. So this is just remainder 0. So our answer for number 10 is just, again, the quotient part. Since we have a remainder 0, we know that the divisor is actually a factor of the dividend. Whoa! That was a long one there, guys. I wouldn't ever ask you to do something longer than that on a quiz or a test, but again, you see that it's kind of the same process over and over and over again, right? That once you kind of get the hang of it, it's just a matter of kind of keeping track of everything, which can be challenging because it's a long process and then there's lots of opportunities to drop a negative sign or like add something wrong or whatever. But it's not a difficult process, it's just time consuming and a little bit detail oriented. Anyone else with questions from this most recent assignment?
Mr. Cook, I have another question if that's okay.
Yeah, that's perfectly fine.
Can we do any problem between 2 and 4? Like any of the addition, subtraction, or I think the other one was multiplication?
Yeah, what do you want to do?
Can we do multiplication, I guess, because that seems a little bit more difficult, I guess.
Okay.
Thank you.
Sure. So if we want to do the multiplication of these, we're just going to be multiplying the polynomial f of x with the polynomial g of x. Just going to copy down that information. And the way I like to do a problem like this is that these multiplication problems can get kind of big. There's a lot of stuff to keep track of, so I like to draw that grid that we did yesterday in the notes. So along one side of the grid, I'm going to put one polynomial. So let's say on the vertical side, I'm going to put this polynomial. It doesn't really matter, but notice here that I don't have any x cubes. So I'm going to put a 0x cubed there. And then on the horizontal part of the grid, I'm going to put the other polynomial. Notice there, though, that I don't have any x squared, so I'm going to make sure I put a 0x squared in that spot. Oops. And I'm going to just draw in some grid lines. And some other grid lines. So I'm just making a little box. And each of these little boxes represents its own multiplication problem. So for example, this is going to be represent 3x to the fourth times negative 3x to the fifth. So when I multiply two monomials, I multiply their coefficients. So 3 times negative 3 is negative 9. And then we add their exponents. 4 plus 5 is positive 9. And I'm just going to continue doing this for every box in my table. I'm going to want a little bit more room than that. Four was getting a little small. Alright, so we'll just kind of continue. These ones with the zeros are easy because really nothing is changing. You just get a bunch of zeros there. Yes, negative and negative is positive. Joe, are you happy with how I filled that table out?
Yep, I was confused with the table before prior to this, so now everything makes sense. Thank you.
Yeah, and then the last step then is to just combine the like terms. And the like terms now, because of the way we constructed the table, are all on these diagonals for each other, so it's pretty easy to find the like terms to add them up. So I just have 1x ninth term, and I have 0x to the 8 plus 3x to the 8. And I have negative 6, 0, and negative 3x to the 7th, so that's negative 9x to the 7th. 3, 2, 0, and 0, so 5x to the 6th. Again, we're adding, so negative 3, negative 1, negative 2, 0, and 21 gives me 15x to the 5th. And then 1, 1, 0, 0, negative 3 gives me negative 1x to the 4th. And then negative 1, 0, 14, 0 gives me 13, x to the thirds. 0, negative 7, negative 2 gives me negative 9, x squareds. 7 and 1 gives me 8x, and then negative 1 at the end. And that would be our final answer, that boxed piece there at the bottom. So again, it's a little time consuming, it takes up a little bit of space, but the individual operations are pretty easy to do. The most challenging part here is just kind of keeping track of everything and making sure you don't make a small error in the course of all these small little multiplication problems and addition problems you need to do. Again, it's kind of easy to goof up an exponent or goof up a negative sign or something like that, but the method there is pretty easy method to do. Okay. Last call on questions before we move forward.
So for number 6, is there supposed to be an A?
Yeah, that's not a mistake.
I just wasn't sure how to do that.
Okay. So let's do that then. So let's try to make some space. So the negative 2a goes on the outside. I'm going to make this kind of long because this will get a little bit messy here. Alright, so negative 3, 1, negative 1. Then we had a 0 because we had no errors. And then we have a 7 and negative 1. Okay with the setup so far there, Megan?
Yes.
Okay. So we bring the first number down. And then we multiply to the number underneath. Write the number there, and then add. So negative 2a times negative 3 becomes 6a. If we add down, those are not like terms, so we just have to write it as like 1 plus 6a. Okay with that?
Yes.
Okay, now we'll just kind of continue. So negative 2a times 1 is negative 2a, and negative 2a times 6a is negative 12a squared. And if I try to add that to negative 1, they're not like terms. So we just have to write it like that. And then we just kind of continue. It's just going to get kind of long and messy. And then when we add down, adding to 0 doesn't do anything. We need to move those, make a little bit more space here. I'm running out, so I multiply by negative 2a again. And I multiply by negative 2a again. Now we add down one last time. And there's our final result. It just got messy, right? But it's okay to have a variable in there or something, like we can handle it. It doesn't change really how we're doing anything. It just gets a little bit messier and longer. Does that make sense, Megan?
Yes, thank you.
Yeah, it looks weird because we weren't expecting to get like these variable expressions as the result of these little addition problems, but it's okay if you do. Like, that's fine. That'll only happen if you're like substituting in a variable, but if you did, you know, it's okay. All right. So today we're going to do two things. So the first thing we're going to do is talk about a polynomial division shortcut. It's called synthetic division. And like all shortcuts in mathematics, it doesn't mean we can use it all the time. We can only use it in certain situations. So synthetic division can only be used if the divisor has a degree of 1 and its leading coefficient is 1. But we encountered some problems like that in the previous homework, right? Let's go back and look here real quick. If I look at number 8, the divisor is x minus 5. The degree of this problem is 1 because that's just x to the first. And its leading coefficient is 1 because it's 1x. So I could use synthetic division on this problem. Similarly, for number 9, its degree is 1 and its leading coefficient is 1. So I could use synthetic division on this problem. Though if I look at number 10, the leading coefficient is 1, but here the degree is 2. So I couldn't use synthetic division to do this problem. I would have to do it using the polynomial long division. Does that make sense about when we can use synthetic division? And you'll see when we, in second semester, when we start doing some more kinds of factoring, that it actually becomes a really valuable and useful shortcut, because we encounter lots of situations where dividing, or the division we're going to be doing, is with these polynomials that have degree 1 and leading coefficient 1. They're often going to be the thing we're most interested in dividing. So let's do an example. So I'm just going to steal the example here from number 8. Since we've done this already by hand, we'll do this same one using synthetic division, just to kind of contrast how nice of a shortcut that really is. Okay? So we're going to do the same problem number 8 as our example for synthetic division. So I'm glad that somebody asked about either 8 or 9 because it gives me a good problem to do as an example. Okay. So what we're going to do is we're going to take the divisor, we're going to set it equal to 0, and solve. And then basically what we'll do is the same synthetic substitution process. We're going to put that number 5 on the outside. We're going to put the coefficients from our dividend in there. And then we're just going to go ahead and do that synthetic substitution process. Bring down the 2. 5 times 2 is 10. We'll add down. Gives me 1. 5 times 1 is 5. Add down gives me negative 7. 5 times negative 7 is negative 35. Add down gives me negative 6. 5 times negative 6 is negative 30. Add down, that gives me 0. So it's the identical process that we used for synthetic substitution. I warned you guys yesterday that that process was going to be useful later on. And guess what? We're done with the division. That was so much faster and really a whole lot easier than doing the long division. And you're looking at me like, how are we done? What do you mean? Like, where's my answer? Well, it's all about interpreting these numbers underneath. So if we start at the far right, the first number is the remainder. The next number is the constant term. The next number is the coefficient for our x. The next number is our coefficient for our x squared. And we just kind of continue increasing the degree of our x's as we move from right to left. So what this tells me then is that the quotient is 2x cubed plus 1x squared minus 7x minus 6 with a remainder 0, so I don't have to write anything else after that, which is exactly what we got when we did number 8 using the full polynomial division method. Look at how nice and easy that was. Massively faster, right? Much less writing, much less to keep track of, much fewer opportunities to make a mistake. It's a really, really, kind of nice and neat procedure. Let's do another, just to kind of get some more practice. Again, we did the synthetic substitution yesterday, so this shouldn't be wholly unfamiliar. Let's not do that. So the first thing we do, we take our divisor, set it equal to 0, and solve. Because that's going to tell us the number that's going to go on the outside of our synthetic substitution setup. And we're going to take our coefficients and put them in. So I have 1x to the 5th, negative 1x to the 4th, etc., etc., etc. Those are all starting to look like 2's. Let me fill in a little bit more highlighting so they don't look like 2's. Let me go back and look at this. Okay. First step is we bring that first number down. 1 times 1 is 1. We add down. Gives me 0. 1 times 0 is 0. Add down. 1 plus 0 is 1. 1 times 1 is 1. Add down. That's 0. 1 times 0 is 0. Add down, that's 1. 1 times 1 is 1. Add down, that's 0. We're done with the division. Boy, that was fast, right? Like, so fast. So remember, these numbers at the bottom now tell us what our answer is. This first number on the right tells us the remainder. We always go from right to left. The next number is the constant term. We have our x coefficient, our x squared coefficient, our x cubed coefficient, and then our x to the 4th coefficient. Again, we're always going to be going from right to left when we do this, and the degrees on our x's are just going up by 1 each time. So our answer then is 1x to the 4th. I could write 0x cubed, but since it's the coefficient is 0, I don't really need to. 1x squared. Again, I could write 0x here, but I don't really need to. Plus my constant term. And then since the remainder is 0, I don't have to do anything else. And I'm done. Talk about a time saver there, folks. That's pretty righteous. All right. Any questions about synthetic division? We talked about when it can be used, and we've talked about how to do it, right? Does anybody else have a question? Okay, cool. So let's start talking about factoring. So we're going to talk about 3 kind of factoring techniques that we can use here. So the first special factoring pattern is the sum or difference of 2 cubes. So a sum of 2 cubes will always factor this way, and a difference of 2 cubes will always factor this way. So let's do an example of how we can use those factoring patterns. Let's say we have x cubed minus 8. So it should be easy to see that x to the third is x cubed. So clearly x is something cubed. And then 8 is the same thing as 2 times 2 times 2. So 8 is something cubed. So like in my formula above, my a is like my x, and my b is like my 2. So I have this situation, right? I have something cubed minus something cubed. So I can now fill in. I can say I have x minus 2. It's my a minus b. And then a squared plus a times b plus b squared. Or if we clean that up a little bit, x times 2 is just 2x, and 2 squared is 4. Let's do another example of that. So let's say we have 125 x to the third plus 27. So because I see that my polynomial has an x cubed and then a constant, I would start thinking maybe this is could be written as the sum or difference of 2 cubes. So I'll start investigating. I really want to know if 125 is something cubed. Well, I know that 5 times 5 is 25, and 25 times 5 is 125. So 25x to the third is the same thing as 5x quantity to the third. And then I need to think about, is 27 something to the third? Well, I know 3 times 3 is 9, and 9 times 3 is 27. So 27 is the same thing as 3 to the third. So my a is like 5x, and my b is like 3. So if I go up to my sum, which is what I have here, right, a sum, I can fill in, I have a plus b, and then a squared minus a times b plus b squared. If I clean that up a little bit, 5x squared is 5x times 5x, so that's 25x squared. 5x times 3 is 15x, and 3 squared.
Mr. Kulik,
Yes.
so are you pretty much just substituting the values for a and b after you figure out what the values are?
Yes.
You're putting it into the equal equation or whatever that is?
Into those little factoring patterns that we listed at the beginning. That's exactly what I'm doing. Yes.
And then you just solve the equation or the pattern, and then you get your answer pretty much?
Yeah.
Okay.
Yeah. You're just using those factoring patterns every time once you've established your values for a and b.
Okay.
Now keep in mind that you can't do that every time, right? So imagine that we have 6x to the third plus 8. this is not factorable because there isn't some number, whole number, that when we cube it gives us 6, right? 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. There's not a whole number in between 1 and 2 that's going to multiply together to give us 6, right? There's no other whole numbers in between. So we can't always use that pattern, even if we have it something that kind of looks like it. You have to make sure that you have something cubed plus or minus something else that's cubed. Okay. The next one, is a difference of 2 squares. And we used this already last semester, or in last chapter, excuse me, for quadratics. But we can still use it now for things that aren't necessarily quadratic. So again, what I want to be able to do is rewrite this as something squared minus something else squared. So x to the 4th is x squared squared, right? Because x squared times x squared gives me x to the 4th because we're adding exponents when we do multiplication. And 16 is 4 squared. So my a is like x squared, and my b is like 4. So it's going to give me x squared minus 4, and x squared plus 4. But I'm not done here. Why not? Well, look at x squared minus 4. That is also a difference of 2 squares, isn't it? Where a is x and b is 2. That's something that we would have factored last semester. But x squared plus 4 is not factorable. Remember, there's not a sum of 2 squares. So that piece is not going to change. And that's our final answer. So the idea here is we can still apply this difference of 2 squares to polynomials that aren't quadratic, right? If they have an even exponent like that, like x to the 4th or x to the 6th or x to the 8th, you might still be able to use a difference of 2 squares to deal with that. Okay. Let's do another one. Let's say we have x to the 6th minus 1. Let's call that b. Okay. Well, x to the 6th is x cubed squared, and 1 is just 1 squared. So my a is like x cubed, and my b is like 1. So I have x cubed minus 1 times x cubed plus 1. But I'm not done here. If you look at x cubed minus 1 and x cubed plus 1, those are a difference of 2 cubes and a sum of 2 cubes, respectively. So we can continue and do a little bit more factoring even still here. So this is like my a is x and my b is 1. Similar to here, my a is x and my b is 1. So using the difference of two cubes, I get this. And using the sum of two cubes, I get this. And that's going to be my final answer. Okay. I think this is probably a good place to stop. So we're going to stop here for today. I don't have the assignment prepared yet, but if you check back by the end of class, of the end of the class period, I will have it ready. And today, we're going to do our last homework quiz for the semester. So I'm pasting that homework quiz right now into the content library and syncing my notebook. So that should be viewable for you guys in just a few minutes. When I dismiss you, it would be fantastic if you would go and start on that homework quiz and try to have that submitted by the end of the class period at 9:05. To submit, I will have a assignment, or I will put a Dropbox in PowerSchool, and you can submit your work there. If you do your work in OneNote, please turn it into a PDF to submit. It makes my life quite a bit easier. And if are there any questions about that?
Mr. Kulik, I'm sorry, I was just in the bathroom, so we're doing this homework quiz right now?
Yes. Yeah, and I'll have a assignment for this most recent lesson posted to the content library here by the end of class. I just didn't have a chance to finish it yet this morning.
Okay. Go ahead.
You can go, Joe.
All right, mine's quick. Can we do the homework quiz on a piece of paper and then just take a picture of it and put it in a Dropbox? I think you said that.
Yeah, that's fine.
Okay, thank you.
You're welcome.
And can I leave and then do the homework quiz off the Zoom?
Yes. So you guys are all dismissed now. So go ahead and you can type bye into the chat and head out and start on the homework quiz. You don't need to be in the Zoom to do that.
All right, thank you, Mr. Kulik.
You're welcome. Have a good day.